to module 6.6, similar and congruent triangles. So in this lecture video, we're going to talk about both similar and congruent triangles. So we're using triangles here as for example, this module can easily be similar and congruent figures. Okay, so let's take a look at congruent first. Okay, congruent triangles or congruent figures. Okay, two properties. Two triangles are considered as congruent if, number one, the corresponding angles got to have the same measurements, all right? And at the same time, to be congruent figures or triangles, the length of the corresponding sides are always going to be equal. So in the figure below here, triangle ABC, and triangle DEF are congruent. So this problem already told me it's congruent. We can write the symbol for congruent as equal with this little scribble up top. Okay, so what that means is if we say these two triangles are congruent, the first thing is the corresponding angles got to match up. So they're using these dashed lines here. So angle A, one dashed line, actually congruent with or correspond with angle D. All right. B is two dashed line correspond with E. So those two have the same measurement. And C has three dashed line correspond with F. All right. So basically, in order to be congruent or similar, the first thing we got to do is match up their vertices. Okay, and make sure the vertices, these angles are congruent. Then the next thing we check is make sure the corresponding sides are congruent. The reason why I color code them so we can see that from red to purple is 15 feet, okay, which is the same as from red to purple on the other triangle. All right, from, let me use green. All right, from purple to blue is 8 feet. Purple to blue is also 8 feet down here. So those two sides correspond and congruent. So now the 12 correspond with 12, which also means they are congruent. So when everything corresponds or congruent angles and sides, we say the two figure or triangles are congruent. Now for the word similar, that's a little bit different. Similar triangle or similar figures, the corresponding angles actually have the same measure, okay? However, the length of the corresponding sides are proportional. That's a key word here. Similar means something of the same. What's the same is corresponding angles, okay? At the same time, their corresponding sides are proportional. So in other words, basically one triangle is just bigger than or smaller than the other triangle. They have the same angle measure, okay? They have the same angle measure, but the sides are actually proportional. So consider the triangle ABC and triangle DEF, where triangle ABC is similar. So this is simple for similar to triangle DEF. So let's make sure we can match up their corresponding angles and make sure they are congruent. So they kind of label them for me. The angle B here and angle E are both 90 degrees. And they made this mark right here is trying to show that angle A is the same as angle D. So therefore, angle C and F got to be exactly the same. So I color code them so they can help me to find the missing sides. So the corresponding sides are proportional. So that means one side is bigger than the other side. On the other hand, you also tell me I can use proportion to set them up. So if I set them up as proportion, so let the first fraction bar for the numbers from the triangle on the left, the other fraction bar for the sides of the triangle on the right. So let's find x first. X is the triangle on the right, so I'm going to put on top. Red to purple, okay, so on the other side, red to purple is 10, put them top to top. All right, I cannot use 6 purple to blue because I don't know the other purple to blue. So I got to use the bottom red to blue, which I put 8 below my 10. So that means these two numbers come from the same triangle, and put 13 right next to it. Corresponding side, put side by side. Put the 13 below the x because both of those numbers come from the same triangle. So I'm just going to have do my little cross product and write my answer in fraction, reduced fraction form. Okay, so 8 times x, we kind of done this back in module 4. 8 times x is going to be 8x. It's going to be 8x set equal to my pen is acting up a little bit. Completely. There we go. All right. 10 times 13, 130. All right. Divide both sides by 8. Coefficient is 8. $130 divided by 8. I'm going to put that in the calculator and let the calculator reduce a fraction for me. All right, no decimal, no mixed number, just fraction. So my answer is going to be improper fraction in this case, which is 65 over 4. All right, so that's what my side x is. All right, now let's find side y. So this is another problem. So I'm put it too close together. Let me move it down a little bit. For side y, okay, side y is purple to blue on the right side. So I'm going to do everything the same. Side y corresponds to the other triangle, 6. Okay. So since I just found x, I can use 65 over 4 against 10. Or I can use the same number that the problem gave me, 8 and 13. So yes, I can reuse the same numbers, you know what I'm saying, because all the sides are proportional. So I'm just going to use the number that given me, which is easy to work with, and key it in the calculator. So a little bit of cross product again. So 8 times y is 8y, set it equal to 6 times 13, which is 78. All right, divide both sides by 78. All right, solving for proportion, divide both sides by 8. I'm going to let the calculator reduce a fraction for me. 78 divided by 8. My answer, 39 over 4. All right, that's all it is. All right, let's look at 2 more triangles, okay? So this time the 2 triangles kind of is kind of inside one another. All right, very interesting problem. It already told me the 2 triangles are similar up here. So let's find our corresponding angles, okay? Find our corresponding angles. So the triangle that's in the inside, I want you to first see this. Triangle in the inside, right there. Triangle on the outside. What you notice here is both triangles shares the same F right here. Okay, shares the same F. So just by the picture, most of us can tell. All right, most of us can tell the J correspond with the H. Okay, the I correspond with the G. All right, so how do I know? Here's a couple of things. How do I know this Y and that 50 degree are the same? So if you think about it, triangle FGH, this triangle in the inside all three angles together got to equal to 180 degrees. So if I take 180 minus my 34 and minus my 96, that will actually tells me this is 50 degree right here. So that's how I know, in a way, that's how I know the I and the G corresponded, because this Y got to be 50 degree. So if this is 50 degree, correspond with the I. Therefore, the H and the X got to correspond. Okay, because remember now, the two triangles share the same 34 degree. So 34, 50, then top here got to be 96. Okay, I just got my two angles, 96 degree, and Y is 50 degrees. So this example is not looking for the side, it's actually looking for the angles. Okay. All right, this one is looking for the sides. Find X. All right, so I don't know if y'all remember this back in previous video, when two lines intersecting at one point, okay, the angles that are facing each other, okay, it's called the vertical angles. So what I got myself here is, I know the two triangles are similar, okay, so, and I also see two lines intersecting at one point here, so this angle corresponds to this angle. So now I know 110 corresponds to this 110, therefore the V corresponds to S. Okay, I color code them so we will use the correct number. So let this big triangle on the left to be on the left of my equal sign, or I set it as proportion. Small triangle on the right. So I'm looking for X. X is on the big triangle on the left, so I'm put on top. Red to black corresponds to red to black. So that means I will put 10 right next to it. All right. Red to blue. Red to blue. 4 and 8, I will use those two numbers, because I cannot use the 16 and the Y because I don't know what Y is. All right. So again, cross product. This is going to be 4x set equal to 80. So divide both sides by 4. My answer, x equal to 20. All right, so I find x to be 20. Let's find y real quick. So again, y is located on the small triangles on the right. So I'm going to put on top. Blue to black is y. So on the big triangle, blue to black is 16. I'm going to put right next to it. So I'm going to use my A and 4 again, just like I did with finding X. I can reuse the same number, or I can use 20 versus 10. Okay, either way will work. They're all proportional to each other. Just make sure you put them at the correct spot. Okay, the numbers on the small triangle need to be inside the fraction on the right. Okay, the big triangle, the one on the left. So you can almost kind of tell just by the A and the 4. That means the triangle on the left is twice the size of the triangle on the right. That's the reason why the 10, that's the reason why the 20 is twice of the 10. Okay. So that means the Y is going to be, on the small triangle, it's going to be half of that 16. So the answer got to be 8. If not, again, cross product will indicate that 8 times y is 8y equal to 4 times 16 is 64. Divide both sides by 8. My answer, y equal to 8. All right. So in this lecture video, we talk about the difference between what a congruent triangle or congruent figure versus similar triangles or figures. Okay. Congruent means all the angles and all the sides for the corresponding are the same. Similar means corresponding angles are the same, but the length of the corresponding sides are proportional. That's why we use proportion to help us to find the missing sides. All right, that will conclude this lecture video. Thank you for watching.